Okay, it's preparing to. And it is live. So cool. I'm gonna post this on Twitter and on Slack, and then we can start. I'm gonna wait a little bit for people to join, because right now took. Okay. Okay. It's on. Okay, Daniel, I leave you to start the session with a few jokes. Okay, anyone has a computer science joke? Nobody?
How's what? Computer science joke.
Or any software engineer's joke.
At the junior league.
And I was on mute. Okay, so welcome everybody. Welcome to this very special session. This session is going to be led by ALX, computer science and software engineering program students from cohort 9 and cohort 10. They're going to go through a few tasks from for cohort 11 specifically, and then something special at the end of the session. But I just want to make sure that you guys understand that they worked very hard and very professionally to put this session together. It's been 2 weeks that they're working on this. So please be gentle with them. If you have any questions, please ask on the chat and we'll do our best to answer all of them. And with that, I'll give the floor and the mic to our DJ tonight, Daniel.
Thank you, Mr. Julian. Thank you everyone for joining. Good evening, good afternoon, wherever you are. It's a pleasure for all of you to be here together with us. This is a session, this is a live learning session, but at the end of it, we'd like it to be fun, to all of you guys. Today we are going to look on at a few things, and allow me share my screen and walk you through the agenda of what we are going to do. So, like I said, my name is Daniel. I'm in cohort 9, and I'm honored, guys, to work you guys to work with us, Team Titans, as we teach or we learn with you guys. Today, our housekeeping rules are normally the same like the ones in ALX. Kindly stay attentive while we are teaching. Drop your questions in the section of that YouTube chat. On our agenda, we have the following. We are going to have activities. One of them is going to be we are going to print numbers. We are going to print the integers by our sister Alice. Then we print most of the numbers from 0 to 9, excluding 4 and 2. And it's going to be handled by our sister Ibinabo. Then we'll go ahead with our brother Joshua, as he'll be tackling the Fibonacci series. I'm pretty excited for this one because it made me scratch my head a lot. But I guess today we're going to have the answer. And on the mail, we are going to be handling Malloc. I know most of us, we've worked with Malloc, we've done what, but have you ever gone ahead and asked yourself what really happens behind whenever you call Malloc into your function? And then last, we'll handle the questions. Yeah. Allow me, call my sister Alice to begin. Thank you very much.
Yeah. Hi, everyone. I hope you guys can hear me. So someone is sharing the screen. Okay, it's okay. Now I can share. Daniel, please stop sharing your screen so I can share mine.
Alice, you're good to go. I'm done sharing.
Okay. Just give me a minute, guys.
So while Alice is setting up her screen, one thing, the reason why we chose, this task is that we know that, everybody around the table has struggled a little bit to print this one. And, like we know, the staff knows that like this one task is a bit tricky, especially at the very beginning of the curriculum, because you have to gather all the knowledge that you have accumulated so far to really understand, how to put this together. And on top of this, there's a little bit of algorithm, like, entry-level algorithm, but it's kind of the first time that during the program you encounter, such a level of algorithm. So it's a very interesting and like kind of tricky problem set that, Alice is gonna take care of. Alice, back to you.
Okay, can you guys see my screen? Okay, so my task was an advanced task from more functions and more nested loops. So basically what I was asked to do was to print integers, all integers, yeah, this was the question. I was supposed to write a function that prints all integers. This was the prototype given, and then I could only use the bootcap function, yeah. Then we were provided with the main.c. And so how to approach this question? Sorry. I'm trying to get my whiteboard. Just give me a minute. Yeah, so here we are. Sorry for that delay. And so we are supposed to print integers. And we'll be doing the entire range from the smallest to the largest. That is the int min to the int max. That is the range from int min to int max. Yeah, and then we'll be using Putka. And what we know about Putka is that it only prints one character at a time. So you can't do all of, you can't do like entire integers, the entire number at the same time. You have to do one at a time. Yeah, and then, so given our, the minimum integer value, you can Google it, but the value would be, it ranges from 21. You can Google it. It's 48, and the largest integer value, or rather the int max, it's yeah, so that's the range that we will be printing using Putka. And then this is actually supposed to be a negative, this value here. So I meant negative this value and then the positive. That's the range that we'll be printing. And then for again, I said we're using Putka. So we'll have to display the negative sign. And for that, that's how to display the negative sign. Or you can use the ASCII value for it. It's in the range of 45, if I'm not wrong. So you can write either that or Putka as 45. Yeah, so that will display the negative sign. Otherwise, you'll just print your integers as they are. I being your n. So you're either printing I equals to the negative value n, or I as n itself. So that's what we'll be displaying, yeah, or rather printing. And then for I being less than n is for all values less than 0. No, sorry, it's for n less than 0. And so to display the numbers greater than 0, that is n greater than 0, we have a different formula, because remember we are using Putka, and Putka only displays one character at a time. So as much as we compute the digits, we are going to convert them to characters for Putka to print. Yeah. And so to do this, for integers greater than 0, to do this, we are going to take our number n, assuming we have a value like 1,245, and we need to print it, but we can't print all of it as it is. So we're going to print one at a time. So we'll start with 1, followed by 2, and then 4, and then 5. But how do you do that? How do you print one number at a time? If you have any questions, please ask. But to proceed, how we print 1,245 at the same time, you take 1, you take the number, and then you divide it by a divisor. Let's just call it a divisor for now. That should give you 1. but how do you know how do you arrive at this divisor? Yeah. And so to compute the divisor, we can name it J. So N, and then we can let our J start at 1 in such a way that N divided by J will give you the number itself. Isn't that true? Because you're taking N, 1245 is our N. And then you're dividing by J, which we have set for a start as 1. For now, we are computing the divisor. We are trying to get this divisor that will divide our number and extract or isolate 1 on its own so that we can print it first. Yeah, so we are trying to compute the divisor. So for our first computation, N divided by J giving us 1245, that's not what we want. We want 1 only. So we are going to sort of increment J. J will be equal to, say, we increment by 10, rather multiply by 10. And then we compute again. N divided by J, this time will be 1 to 4. Yeah, because you're dividing the number by 10. Is that understood? Okay. And then we still want to print 1 only. We're at 124, so we'll need to increment J again. J again. And this time when we divide N by J, we're going to get 12. But that's still not what we're looking for. So again, we increment J again. And this time, when we divide N by J, we'll get our 1. And so to get our divisor, there's some sort of loop that is showing up. And so to get our divisor, basically what we are arriving at is N divided by J. And our J in this case, it will be a multiple of this here, here, and here. Of course, you can include the 1, but any number multiplied by 1 is itself. So we have the first time, second time, and third time. So which is 1,000 to give us 1, which is the number that we want to print. Okay. So in our code, we're going to keep in mind that we have a loop and we need to keep track of this J, how many times it's been executed. And to do that, we're going to include a variable that will help us keep track of how many times we've executed the count, the J, sorry, using the count variable. So the count will help us keep track of the number of times we've executed our J. And then, so that's just for printing the 1. So now we need to figure out how to print the rest of the numbers. Yeah. So we figured out how to find the divisor. And we found that we have a loop. We'll have a loop in our code. Now we figure out how to print the rest of the numbers. Okay, so far so good. And so to do that, we're going to take our N again. We divide by 1,000. That will give us the 1 as we had done before. And then from there, we print. We are going to print our computation. we are going to print our computation, and we still want to move to the next number, so we'll use modulo. While you're dividing n, our n, remember, was 1245, and to get the remaining numbers, we can use modulo. So at 1245 modulo 1000, that will give you the remaining bit of the number. So it's sort of like you're extracting this number. Yeah. And then from there, you take j and you divide it by 10. Remember, our j was this number here. Oh, sorry, I didn't include this. So maybe if we can just comment. So this one is, assume this is the comments from how we write comments in code. So this is isolating. This is the printing bit. This is extracting the remaining bit of the number. And then from here, j divided by 10 is moving to the next number. Moving to the next number. I don't know if that's understood. If you have any questions, please remember to ask. So moving to the next number, so we'll take our n again. And our n this time is 245. And this time we're dividing it by 100. Remember, we have reduced j by 10 from this bit here. Yeah. So when you divide 245 by 100, you're getting 2. Then we need to print this number. We're printing using putscar. And then we need to extract the remaining bit of the number using modulo. Sorry, this is n. The remaining bit of the number will be 45. Yeah, is that true? That's the extracting bit. And then we divide j again, or rather we reduce j to be able to move to the next number. And so we do this again. We are forming another loop. And so we have n again divided by 10. And 10 is coming from this operation here. And this will give us the 4. Because our new number is 45, we're dividing by 10 to get 4. And then putscar is for printing, and divide by 10. And then we extract the number again. Using modulo. So 45, the modulo for 10 should be 5, yeah? And then we divide j again. Yeah. So our new number is 5, yeah? So we have n. N divided by 10. Or rather, n divided by 1 should give you 5. Then we print this number. And then we check the modulo again. And this time j is equals to 1. So that's the end of our loop. So we have a second loop here. The first loop was for getting the divisor, and the second loop will come in for while printing and extracting the modulo of the number. So we'll be printing one at a time. I hope that is understood. Now moving on to code. So moving on to code. So I had pre-created the files as given by ALX. So we have our main.c, which is exactly what is provided here. I don't know if I should do both of them or just one. No, let's just go by one. So it's exactly as provided in the tasks. And then we have our main.h for our header files. And then we have our putka. Remember, we're using putka, and putka is already provided by ALX. So we're going to create a new file to code our solution. I name it print numbers. Let's see. And so to print this, just allow me to run through the beginning of the code. So we're including our main.h, and then we're going to write our descriptions. We have print number, which prints the value of all integers. And then we'll probably use, okay, or rather we'll come back to that. And then we don't have a return value. Okay, so we can go to the main part of our code, which is the prototype provided. And we need to define this n. So we'll go back to the descriptions and say that n is, say, an input integer. Okay.
Alice, would it be possible to increase the text size, please?
Yeah.
Thank you.
Is that better?
Yes.
Is that better? Yeah. Okay. Yeah. Okay. And then from our whiteboard, maybe we should just go back to our whiteboard for a minute. Oh crap. I've accidentally closed my whiteboard. Just give me a minute. Mhm. So I'll just start that again. Sorry. Just repeating what I did earlier. I accidentally closed it. So the prototype, yeah, back. So I was trying to explain the data type to be used. And from our whiteboard, we had talked about printing the range of values from the smallest integer value, the int min, to the largest integer value, the int max. And realized that if you use, we realized that if you use int as it is, it may not accommodate all of the integers because the value of the int min, the smallest value, will not be accommodated while using ints. And I'll show you why. But just to explain what I'm doing, we're going to use unsigned int, which is the largest, or rather the next largest integer or data type that we can use. And for this one, we will have I. We had I in our sorry. We had I in our whiteboard. We had J, and we are also including count as a data type. Okay. And then, so we'll start by saying that for all numbers that are less than 0, we want putka to include the negative sign. And this is how you include it. But you can also write the ASCII value for it. So instead of the dash in quotes to print it as a character, you can include the dash, the ASCII value, which is 45. So writing that is okay as well. The ASCII value for the negative or the dash is 45. Yeah, so we want putka to print that for all values of I. For all values of I that are negative numbers. And if that's not the case, for the positive values, for the positive values, they'll be printed as they are. So I will be equal to N. And so I was trying to explain that for this concept here, I equals to negative N. if we use the int as our data type of choice, it will not include the smallest value of int, the int min, because taking the absolute will cause an overflow, taking the absolute value of the smallest integer value. So that's why we're using the unsigned int. And the range of this, you can Google it, is twice the range of integers. So that's why we're going for the next largest data type. I hope that is well understood. Let me just include these semicolons here and here. Okay. So from here, we're going to define J. We've already worked on I, so we're going to define J, and J is from our whiteboard. Can you remember J was an integer? And we're defining it as a variable as well. It's an integer, I. We can equate it to I, or just say that J is an integer. And then we also need to define our counts, or rather equate it from where we'll start. The count was giving, or rather the count was keeping track of the number of times we computed the 10 while calculating the divisor. Yeah, so we can leave this at 1. We can start it off as 1. Okay. And then so from our first loop, I'm just going to type it from memory because I accidentally shut down our whiteboard. Yeah. So we have a for loop for the first one to compute the divisor, the J. And so we're going to do that for J. Let's use while. While J is greater than 9, and we want to ensure that our J divides 10, or rather is a multiple of 10. We want to keep track of this while ensuring that our count comes from the number of times we got 10, or rather the multiple of 10. Okay, I understand 20 is also a multiple of 10, but this time we're including the number of times it has been included in our loop. Say if it was included twice, then it's 10 multiplied by 10, that's twice. So that's what this piece of code here means. And then we can move to our for loop. So this is the first part. This code right here is for computing the J, the divisor. So the next part, we're going to be computing how we'll be printing the numbers one at a time. Yeah, and for this, we'll use a for loop. And for the for loop, we're working with a count. So you can say count, for count equals to 1 as our initialization, although you'll notice that we've already done this before. It's already here. So you don't have to repeat it again. You can bypass it and just leave the semicolon. So starting our for loop with a semicolon pretty much indicates that we are bypassing the initialization because it's been included elsewhere, which is here. So we're going to work with count greater than 1, greater than or equal to 1. And we need to ensure that our count divides, or rather is a multiple of 10. Yeah, and so for this one, this is the part where we are printing. So for this bit, sorry. So for this bit, we want Putka to print our number n divided by our count, which is, if you remember from our whiteboard, which is the formula we were using to get the, to isolate the first value of the number and print it. And then we also want to compute the modulo being a base of 10, or rather coming as a multiple of 10. And all this computation will give you a digit. This computation right here, from here to here, will give you a digit, but we want to print this as a character. We want to print the numbers as character. You know, remember we're using Putka. So it will be plus 0. So that basically means that you're printing the numbers as characters. And you can use the ASCII value as well. You don't have to write plus 0 as it is. 48. So it's okay to write 48 if you want. Yeah. And so this piece of code right here will compute what we were doing on our whiteboard. That is printing the numbers, isolating the first value of any number that's greater than that's greater than 9. You isolate the first number, you get the modulo of the remaining, and then you extract it as it is, and then you move on to the next part of your number. So yeah, so that's our code. I don't know if I forgot any semicolons, but we'll run betting. But that's really our code. Yeah, and so we need to compile this. We need to compile this, and for compiling, we were given this. So I'll just copy that. So on compilation, oh wait, what did we name our file? Print numbers, okay. So we'll just change this to print numbers. There. Oh, we named it 100. Hmm. 100 print numbers. Yeah, and so it has compiled. And then to see if our number works, because we already have the main.c, we're going to get the outputs. And so our code works. Yeah, if we can just open the main.c just to see what we were trying to compile. just to see what you were trying to print rather. It's this one here. So we have the 8, the 402, the 1024. So this is what you were trying to print. And the code works. Yeah, so are there any questions? Daniel, maybe if you can just update me if there are any questions before we move on.
So far, there's no question. Can you show the code one last time, please, for everybody to look at it?
Okay. This one right here.
Mm-hmm.
So we're using the unsigned 8 as the data type, as I explained earlier, because it will cover the entire range of integers from the smallest to the largest. Using int alone will cause an overflow because of the int min, the smallest number. Taking the absolute value will go above, given that we're using this formula right here. And then the count variable is just to keep track of the number of times 10 is computed while calculating our divisor. And then this piece of code here is for printing, extracting, and then moving on to the next number. We are printing one number at a time. Is that okay?
Thank you, Alice. This was like a very clear presentation. It was really good. And I saw on the chat that like a few students are thanking you because they've learned something. So that's pretty cool. Congratulations.
Thank you. I'll stop sharing.
Daniel, back to you.
Okay, thank you, Alice. Thank you for the wonderful explanation. I hope one or two of our brothers and sisters have got something to learn. Next on agenda, I'll go straight to the next activity, and that's printing most numbers from 0 to 9, but we are now excluding 2 and 4, and it's going to be done by our sister Ibi. And remember, we are using putka. We are not using standard, like we're not using the standard printf function. Yeah, the mic is yours, Ibi. Thank you.
Thank you, Danny. It's Ibinabo or Ivy. All right, so I'll just go straight to the point and share my screen. Can you all hear me?
Yes, we can hear you.
All right. So the task we are to do today is under more functions and nested loops, and it's under task 4. So I'll just read it out. Write a function that prints the numbers from 0 to 9, followed by a new line. And we should make use of this function prototype, void print most numbers. And we should make sure we don't print 2 and 4. And then another rule is that we make use of putchar, and we should not use it more than twice in our code. So let's head over to our whiteboard and try to write out everything we need to do, and also write out the rules so that we follow it while coding. So our task, I hope the font size is, let me increase the font size so that everyone can see. Okay. Task, print most one back. tax print most numbers. All right, so the rules we need to follow are: one, use putcha underscore putcha and not more than 2 times. Then also, we should print 0 through 9. Why is it changing the font size? Okay. With the exception of 0, of 2, and 4. Now, at the end of the day, what we'll be able to learn is to know how to create functions and nested statements. So first of all, let me write out the steps we're going to follow. My font size keeps changing. Steps. 1. We'll create a function and we'll call it void print most numbers. Print most numbers. And it's not going to carry any parameters. It's not going to carry any parameters. A parameter is basically a variable that's called while declaring a function. So this void in front of it, excuse me, let me just increase the, okay, this, is this okay? Okay, so I was trying to explain the syntax for writing functions. First of all, you have a return type. In our case, it's going to be null, so you can just put void there, and then the function name, and then your parameters. So that's like the syntax for a function. Then the next thing we'll need to do is to create a variable char C. We'll just call it C. And we are using char or car, depends on how you call it. I call it char. We're using C because we are printing with putcha. Because we are printing with putcha and we want to print single characters. You might ask a question, why C? Why the letter C? In C language, every character boils down to, is interpreted into a number. So when we go on the sandbox, I'm going to open the ASCII code, which is the American Standard Code for Information Interchange. It's like a dictionary where you can see the different alphabets, the different characters. In short, everything on your keyboard is converted into numbers so that it can be easy for the computer to convert it into binary for execution. So we're making use of putcha. So let's just continue. After creating char C, we initialize this char C in our loop statement. In a loop statement, and then because of the exception of 2 and 4, we need to nest another statement for this to be executed. And I'm going to make use of an if statement. Okay. And at the end of the day, we're told to print on a new line. So I'll use putchar to print on a new line. All right. So that's the rundown of what I'm going to do. So I would like to head over to my web terminal. So I've created the header files and the main.c file to save time. You can see it here. And I included the putchar file, which is given to us by ALX for us to use the function. So I'll just go ahead and create a file for solving this solution. So I'll name it print underscore most underscore numbers dot c. Excuse. I for insert, and then I'll include my header files. Include main.h. Include Okay, so I'm going to write out my comment, giving a description of what this file will do. So it's going to return void. Okay, so that's for my comments. And then I'll go ahead and in my header file, I declared my function, but I did not initialize it. That's because you can use one header file for different files. So in case I have other programs that I would like to run my print most numbers, if I initialize it and declare it in my header file, it's going to affect the other program. So it's best practice to just declare it in the main.h, and then in the folder you want to use or in the file you want to use, you complete and you customize the function to how you want to make use of it. So let me go ahead. Numbers. So I will set my car C here, initialize it within the function, and then I put the loop that I mentioned while whiteboarding. So for C, excuse me, for C, being, now remember C, we are seeing C as a character. So while printing characters, you make use of the single quotation marks. So for C being 0, C less than or equal to 9, C plus plus. Okay. Now, this for loop, what it does, it first of all initialize C to 0, and then saying so far as C is less than or equals to 9, you should increment the value of C. Now, if we just do this and type our putcher, it's going to print the value of C from 0 through to 9 without skipping 2 and 4. That's why we need our if statement, so that it's going to exclude 2 and 4. And now for that, in our if statement, we're going to make use of a logical NOT. Now what a logical NOT does, is it negates whatever expression, or condition you write. I just noticed that I've been using caps for my C. Betty would have frowned at me. It's small c, sorry. Okay. Good. Okay. If that the exclamation mark is the sign for the logical NOT. So I put it outside the statement I'm about to write. So if C is equal to, now the equal to sign is two equal signs, while the single equal sign is used to show the value of C. So if C is equal to 2, or this is another operator. It's called the logical OR. It's used when comparing two variables or two statements or two conditions. Okay. C equal to 4. Now close our double brackets. So here you can see we're saying C is equal to 2 or C is equal to 4. Now this logical note, excuse me, would negate this so that while the for loop is printing the numbers, it skips 2 and 4. If you have any questions, please drop it in the comment box. Once I'm out of this, I'm going to try my best to answer. Okay. So now say put char. Close the loop. Okay. And we are asked to print followed by a new line. So once I'm done with this, I'll open the ASCII table so that you can see where the characters, all the characters have their equivalent decimal or hexadecimal numbers, including new line character. /n. Okay. 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 All right, so save. And GCC and compile. Okay, and there we have it. We printed out our 0, 1, 3, 5, 6, 7, 8, 9, with the exception of 2 and 4. So let me CD out of here and show you guys the ASCII code that I talked about. Okay, so here you can see it's like a table. Let me expand this. Okay, it's like a table that shows all the characters, with their equivalent numbers. It's very long. My screen can't contain everything, but you can see the new line character I talked about. Yeah, so that's it for the tax. And I don't know if there's any question. All right, so let me stop sharing my screen.
I think there's one question in the chat.
Okay. I can't see it.
I thought I was reading like, why are you using the OR operator? Did I? It was there and it disappeared. So probably the person has their answer. Okay.
Okay.
Sounds good. It was like super well explained. Thanks a lot, IB.
Okay, thank you, IB. Thanks for that cool explanation. I believe everyone is okay with whatever she has been explaining. Now, next on our agenda, we are going to try and spice a bit up. It's the Fibonacci series. I know we come across them. I'm one of the guys who are really happy that at least I'm going to learn from our brother Josh how it's done and how you can crack it. Mr. Josh, you're welcome. You're welcome on board. The floor is yours. Thank you.
Josh, you're on mute. Just making sure you know that.
Okay, good evening, everyone. Good evening.
Hey, Josh, it works.
Okay. Okay, good evening, everyone. I'm Joshua from Port 9, I think. So I'm gonna be solving this Fibonacci question. Can you all see my screen? So it says, write a program that finds and prints the first 98 Fibonacci numbers, starting with 1 and 2, followed by a new line. So ordinarily, this part should not be a problem. I mean, like, this part should be fine. But then as usual, ALX comes with their restrictions. And so you have all of these restrictions here. It says the number should be separated by a comma followed by a space. That's okay. And then it says you're allowed to use the standard library, which is something exciting because, you know, ordinarily this will not be, I mean, this option will not be available. But then you start getting, you know, start getting scary when you read the last 3 conditions. So it says you can't use any other library. You can't use GMP. You cannot use long. You can't allocate. You can't use pointers. You can't use arrays. You can't use structs. And then you are not allowed to add code any number. Now, these options you will consider, these last 2 options, you will the last 3 actually, you will consider because the Fibonacci number gets pretty big pretty quickly. So I'm just gonna open my whiteboard, which is a simple doc. Let me see. I don't know why it's. Okay, so let me remove all of this. So the Fibonacci number is a sequence such that a given term in the sequence is the sum of the previous two terms, right? So if you're going to get the third term, this term here, term t, you're going to get it by summing these two previous terms. So in this case, t is going to be 0 plus 1. That's what gives you the current term. So when you evaluate that sum, you get t as 1. And then if you want to get the current term, which is the fourth term, it's going to be t this time around being 1 plus 1. So that is the sum of these two terms here, right? So that evaluates to 2. And so on. You add 1 and 2 to get 3, and then 5, and then 8. You have 13, 21, and so on. So it continues like that. But the issue is by the time you're getting, this is like 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the first 9 terms. By the time you're getting to the 50th term, right? It's already over 1 billion, actually over 10 billion. So it gets pretty big. So now you have to add code the first two values, because you can't get the first value because there are no two previous values, right? And then you can't get the first value the second value from any other thing because it doesn't have up to 2. So you have to add code the first two values, 0 and 1. You have to add code them, and then from the third value upward you can compute. So now the commonest starting values are 0 and 1. Most Fibonacci sequence start from 0 and 1 as the first two terms. But in the task, in this task, we have been told specifically that we should start from 1 and 2. So we're going to start from 1 and 2. So that's what you have. So we're going to start from 1 and 2. So these are the two values that we're going to add code. So now let's have a variable term, which is the current term. The current term is going to be the sum of the two previous terms. So we can assign a variable A to hold the first term, and then a variable B to hold the second term. So basically, to calculate term, we're just going to have term equal to A plus B. So this is the algorithm that is going to calculate the terms of the sequence for us. This right here, A equals 1, B equals to this, is going to calculate, is the algorithm to calculate the terms of the sequence. So, but if you just have it like this, you're just going to get term equal to 3. And then you only have 3 values. So what do you need to do to get the remainder, the rest of the terms from the 4th to the 50th or to the 90th or whichever value you want to go to? So what you do is you keep repeating this expression, A plus B. You keep repeating term equals A plus B. But this time around, your A and B have to be moving. So let me see if we can demonstrate this in a spreadsheet. So if we are starting with 1 and 2 as the first two terms, then we can have A here, and we can have B here. And then term will be equal to A plus B. So in this case, term is going to be equal to 3. Now we want to get the next term, which should be the sum of these 2 and these 3. So if this equation is still going to hold to get our 5, what we need to do now is to change this B, this 2 that was our original B, we'll change it to A. So we're going to have A is equal to B. So that makes A becomes 2. And then we're going to have B is equal to C, is equal to 10 rather. So this is going to give this is going to give 3 currently. So this is going to be 3. So then B is equal to 10. So B is going to hold the value 3. Such that when you evaluate, please ignore the minus. I don't know why the Excel is behaving like that. So when you evaluate the expression again, 10 equals A plus B. It is no longer adding 1 and 2. It is now adding 2 and 3. Because after using 1 and 2 to get 3, then you move away from 1 and 2 and then move to 2 and 3, right? To get the current term. So 2 and 3 are going to add up to get 5. So that is the trick. So let's go to the terminal now and then code. So let's open the file as fibo.c. So we want to print, this function is basically printing out numbers. So we're going to include the printf header file. Who knows what the printf header file is? I mean, like, if you're not sure what the header file for any function is, you can always man the function. So if you man printf, you're going to get the header file as stdio.h. So then we're going to have our main, which should return an integer on success. And then so we want to have 3 variables based on what we discussed in the whiteboard, right? So we want to have a variable A, a variable B, and another variable term. So we want to have those 3 variables. Now, those 3 variables could be char or int or strings or float or even double. So in the context of what we want to do, which of these types should we use for our variables? I'm trying to look at the comments. Which of these types should we use? Okay, so it is appropriate to use int. So we're going to have int, and the name of the variables are A, B, and term. So like we said, we're going to add code the first 2 terms. A equals 1, for total start with 1 and 2. B equals 2. So then we want to print them. Print f %d and then A, comma B. So let's print this out on the terminal, and this function should return 0 on success. So let's see the output. We're going to have gcc fibo.c. Okay. I added one specifier, whereas there should be 2. So there's one specifier %d to hold the place for A. So I need to include another one to hold the place for B. Oh. percentage T. So this should work. Let's compile and run. Okay. Please, can anybody spell what this error is? Yeah. Anybody knows what the error here is? This is supposed to be a simple print statement. Oh, I think it's a comma, right? Okay, so this is the output, 1 and 2, which is not well formatted. If you go back to the task, they have given us the format that they want. So they said here that the numbers should be separated by a comma followed by a space. So we're going to modify the code quickly to achieve that. So fibo.c, and then right here on, I know Vim can be frustrating sometimes, but please bear with us. So I've added the comma and the space, and then just for clarity, I'm going to add a new line also. So if we recompile and run, so we have it for the first two to celebrate. Now we have 96 more to go. So like I said, we need to calculate from the third term going forward, we need to calculate using this formula. Term is equal to A plus B. But then we need to be moving the values of A and B. So if you start with 1 and 2, right? If you start with 1 and 2 as your A and B, as soon as you've used 1 and 2 to calculate 3, you now want to move 1, right? You want to move A that was holding 1. You want to now make that A hold 2. And then B that was holding 2, you want to make it hold 3. So that it's 2 and 3 that will now give you your current term. So you get 5 here. And then once you've gotten this 5, you also want to move the A that was holding 2 to now hold 3. And then B that was holding 3 to hold 5. So that the A and B added together can give you 8. So you want to keep moving them like that. So which is why we said this is going to be the base formula. Term equals A plus B. But then as soon as you finish calculating that, you move A to be equal to B. That's like if A was 1 and B was 2. So when you say A is equal to B, that means you moved A to now hold 2, which was the old value of B. And then B equal to 10. So meaning that you moved B, which was holding 2, to now hold 3, which was what 10 was holding. Do you understand? So we have to include that. So and then what is that now? And then we're doing this repeatedly, so we're going to need loops. We're going to need a loop basically. So back to the terminal. Let me make this a little bigger. I think maybe not here. I make it bigger. So we're going to have a for loop now. You need a counter for your for loop. So let me declare a variable k, right? Variable k that we'll use to count. So you have for k equals, now k is not going to start from 0 because we already have the first two terms printed. So we're going to just start from 3. Is everybody clear on that? We want to print 98 terms, and then we've already printed the first two, A and B. Those have to be hard coded. Only doing calculation before printing from the third term upwards. So that's why k is going to start from 3. Then k should be less than or equal to, how many times do we want to print? 98, but let's not get ahead of ourselves. Let's just print 20 for now. And then we can increase it as we go. k less than or equal to 20, k plus plus. So we just want to increment in steps of 1. So what do we want to do in this loop? We want to have c to be equal to, there's no c, so this is going to give us an error. I meant term is equal to a plus b, right? So that will calculate the third term. And then before we exit this loop, let me remember to put braces. You know, these days, we're doing Python, you may forget some of this syntax. So term equal to a plus b, but before you move away from this loop, like I said, you want to assign b to a so that it moves forward after we have used it on line 14, right? We've used a on line 14. We want to update its value to the next one in front. And then b will now be equal to 10, right? So you update a and b, and we've already calculated 10. You can't come back here and calculate 10 again. You're going to confuse compiler. So all we have to do is now just print f. Just print f what the term that we've calculated. So that's going to be, since it's an int, that will be percentage d. You can Google format specifiers if you're not sure which one to use. We're using percentage d because our variables are integers. So if you remember from the terminal, we added comma and new line at the back of comma and space, I meant at the back of 1, but we did not add comma and space at the back of 2 because it was going to look awkward. So if we print this like this, it's just going to merge the third term together with the what's it called? Together with the second term that was already printed. So what we want to do is let's put comma first and then space. So this will ensure that this comma and space is first of all added to the back of 2. And I added this new line for, you know, to make things clear on the terminal. So we're going to have to remove it. We don't need it again. So this is going to be 2, but before we print sum, we're going to print comma and space, you know, just to make it well formatted. So that's what we want to print. And I'm going to remember to add comma and not have that kind of issue with GCC again. Okay, so we want to print 10. So I need to close this loop. So this should give us up to the 20th term. Up to the 20th term. I was supposed to load a page, a web page that shows all the values so that we can compare. Beforehand, I just completely forgot. I hope my internet is fast enough to get that for us. So these are the first 20 terms. So okay, let me quickly load the page for the Fibonacci. First 100. First 100. Okay, I think I've seen this page before, so let's use this page so that we can easily compare. So in counting, we are going to have to discount this 0 and 1 because we are starting from 1 and 2. So our own first term is their second term, and then our own second term is their third term. So if you want to check the 20th term, it's actually going to be their own 21st term, which is 10,946. That should be what we get on our terminal. I'm not seeing. It should be though, because I just have, okay, let me minimize this. Okay, so let me also add a new line. Let me add a new line for formatting. So at the end of the loop, I hope everybody knows I'm not supposed to add a new line in the loop so that it doesn't print, you know, it doesn't print a new line in each iteration. So I'm going to add it like this so that my vagrant prompt can be on a new line. Okay, so 10,946, it matches what we have here. So now let's inspect this carefully. This int that we have used is going to fail. This int that we have used here for all these variables on this line 5, the int is going to fail because int has a maximum value it can hold. So now let's look at the values and then try to guess when it will fail, at what point it will fail. 4807, 526. I think it's going to fail on 48. So can anybody guess at which term is this going to fail, right? Because this is 2.9 billion, right? This is 4.8 billion. So we have to check, can int hold 2.9 billion? Then can it hold 4.8 billion? We don't have to, we don't have to guess it. I just want to know if people are familiar with it already. At which value is it going to fail? It's somewhere between 45 and 50. One of these values is going to make our hint overflow. So anybody? Okay, so so we don't have to bother about that. Let's just increase this to 50 and see what happens. Let's increase this to 50 and see what happens. Right? The code we've written is actually the bulk of it, so the rest is just modifying. So can anybody notice that from here we have started having negative numbers? So if this is the 50th, this is 49, 48, 47, 46. So it's failing on the 46th term, meaning that I can only hold up to the 45th term. This is the maximum value that I can hold. And that is because, that's because integer has a maximum value. I have a file to demonstrate that. So let me vi num.c. nums.c. So now this header file limits.h will help us interpret any limits, that you want to print. Something like, on this line 7, I gave k an actual value, but I could also have done k is equal to int. What's wrong with him? Int max. I could do this, and this will print, right? This will print because I added this header file limits.h. So with this header file, you can do print, you can do int max, you can do this. This one means unsigned integer max. You can do this unsigned long max. All of them are going to print. They are going to evaluate. This header file is going to help interpret them. But without this header file, you're not going to be able to do that. So let me just leave it as int max. Let's print int max and see what happens. So let me GCC. I hope I added print. GCC nums.c. Oh, thank God. Seems that's good. A.out. So this is the maximum value of an integer, just about 2.1 billion. So that was why I could easily print 1.8 billion. But the term after 1.8 billion was already around, I think it was already 4-point-something billion, or maybe 3. I can just confirm and not stress myself, right? So this is the 1.8 billion. And so this is the next thing that we was trying to print. 2.9 billion, which is way higher than 2.1 that we go for integer max rather. So 2.9 is bigger than this. So it's going to overflow. And somebody will say, 2.9, 2.1, why is it not showing the excess, which is just 900? No, it's not going to show the excess. This is what happens. This is what it's going to do. Is this where I want to go? This place. Let me use this. So I think we're good with this. I can clear it, right? If you want to look at it again, just rewind the video later on. So what was I going to do? Okay, so on sign int max is 214788. I don't want to code. I can't code the exact number. So the range of integer values. What's this one showing? 2147668. So this is int max. Okay, let me just use a small number, 214. Assuming this is the maximum value of integer, then int min, which is the minimum possible value, will now be 215. So this is how numbers are structured. The int max, and this is min. Min is one value higher than max. Let me actually make it 215. So, and that's because this one includes 0. 0 is added to part of the positive ones, right? So the negative ones are 215, the positive ones are 215, including 0. So now, if you now want to print 216, 216, since it cannot hold more than 215, what it does is, this is like 214 plus 2. So this is how it counts. After 213, it goes next to 214. And then after this 214, the next thing it goes to is the int min again. It goes to start from the beginning again. 215, minus 215 rather. Then minus 214. Then minus 213. So, I didn't edit this cell to hold big number. So minus 213. And then minus 212. So this is how it goes. So when there's an overflow of 1 from 214, what gets printed is minus 215. And then when there's an overflow of 2, it is minus 214 that gets printed. We can demonstrate that. So this is okay. Let me go back there and change this to int min. Or let me just save time and go back to my terminal and copy this. So if I assign k, if I assign this value to k, so I have k sometimes to enter insert mode, it's stressful in pain. So this is k. This is going to print no problem. But if I increase this by 2, right? So that means there's an overflow of 2. What do we expect this to print? Anybody? Remember, if there's an overflow of 1, this is 21, this is 47, this is the maximum. So when there's an overflow of 1, it's going to print the next one, which is actually negative 2148. This is what it's supposed to print. But if there's an overflow of 9, then what it's expected to print is this. So you can look at that later so that we don't dwell too long on it. So if we try to print this, that's what it's going to give us. So let me recompile this and then run it. So it gives this, which is an overflow of 2 from int max. So that's how this one works. So that extra, this actually was 2.9 billion, right? and then the maximum value is 2.1. So that extra 800 million, right? He added it to the negative 2.1 billion. And that's why you are getting negative 1.3 billion. I hope that makes sense. It was supposed to be 2.9 billion. It overflowed by 800 million. Then that 800 million is going to start counting from negative 2.1 billion. And then you end up having 1.3. So that's how that one works. That's enough on overflow so that we don't sleep here. GCC, the other file we're working on, people.c. I didn't mean to GCC it. I meant to Vim into it. Vim. So Vim people.c. So a quick fix. Now remember I said that this one is actually 215 digits because 0 is included, and this is also 215 digits. Now that's because you are using them as signed, right? You're using them as signed. This cell is also not right. Let me move to another cell. You are using them as signed. So if you just use it as unsigned, then it doesn't have to share the 430. It doesn't have to share the 430 into two parts, the positive ones and the negative ones. It doesn't have to share. That way you can hold twice as large. So you can hold up to 430. Do you understand? So one quick fix to our current problem is that we should use unsigned int instead of int. So how do we change that? This is just going to have unsigned, and that fixes that. But if we fix this, this is not going to compile, as I expect some of us to know, because this %d, right, is for integers. So the appropriate one is u for unsigned integers. So you're going to have u here also, and I think we should be good. So if we GCC, okay, and we try to print, so you can see here that the 2.9 that was not printing is now printing. Then, but here there's another overflow. So this one now, since it's unsigned, after it overflows, the maximum value is about 4.2 billion. After it overflows 4.2, it starts counting from 0 again. So I expect that this number that is trying to print is probably like 4.7 billion, right? We can confirm from that that web page that I had. Okay, yeah. So our unsigned fix was able to print just one extra, printed 47 successfully, but on reaching 48, it already overshot 4.2 billion, which is the maximum value of unsigned. So what is the fix again, right? What's the fix? BI Fibo.c. Anybody, what is the fix? We've tried int, it didn't work. It could not hold more than 48. Unsigned int, it did not work. So what can we use again? Anybody, I'm looking at the charts. Okay, for the sake of time, we're going to use long, right? So long on a 64-bit machine can hold way more than 4 billion. It can hold like 20 digits. Is it 20 digits or 18? Just a very large value. So we're going to use long instead. Now let's go back to the task. As of today that we are doing this task, we are safe because what they said we cannot use is long. We cannot use long. So we can use long. Long is a different data type. Long is a different data type. So we cannot use long. This is not allowed. As you can see, it's a data type, but we can use long. So let's use long, and then that should fix our problem. WQ, let's recompile. GCC. Oh, the format specifier. Somebody should have told me. Right? Somebody should have told me. WQ. What am I typing? Yeah, I wanted to do this. So the format specifier, as I noted earlier, U is for unsigned integer. So for long, I think it's LD. If it's not LD, please someone should drop the correct one in the chat so that we save time. But I think it's LD, right? I think it's LD. Yeah. So when you have a tax like this, it's not just about saying, you know, like when you read the restriction, I start saying, share you the wine. That's not what's going to fix it, because the tax is still going to be there. So this time we're able to print all of them. 2035, this is the 50th number. We can confirm from here that the 50th number, remember I said 50 to 51 because they started from 0, we started from 1. So this exact number we have on our terminal without any problem. So that prints. So we're good, but not completely, because this tax is about printing up to 98. So remember we started from 20 and we moved it to 50. We had issues trying to print up to 50. We fixed all of those by using long unsigned. So let's see how far our long can carry us and just go all the way to 98. Oh, I'm not in insert mode. Maybe I'll switch to Emacs. So let's go all the way to 98. You know, basically, oh, this is one of the things that are frustrating about Emacs. Sometimes it does this. Maybe it's Emacs, maybe it's vagrant, I don't know. We need to wrap up quickly. So we want to print all of these. Like, okay, long, I don't need to change the specifier, so I can just recompile and then test the output. So it prints. But then there's also overflow. Overflow starting at this place. Overflow is starting here. So this overflow that is showing negative means that we're using signed long, right? So we should better just use. So now look at it. How many values are not printing appropriately? 1, 2, 3, 4, 5, 6. 6 values are not printing appropriately. So we're able to print up to the 92nd. It should be 92nd is this 754 forever. We can just quickly check that. The 92nd, right here. 92nd will be their own 93rd. Oh, somebody is maybe I didn't count properly. So this is 92nd. So it's printing this properly for 1, 2, 3, 4, 5, 6. It's not printing the last 6. Well, okay. This is not going to print up to 98. This is not going to print up to 98 because I use less than, so it's going to stop at 97. I should use less than or equal to. What is the problem again now? Okay, so this is going to make it reach 98. So if I recompile now, the difference is that it's 7 digits now that will overflow. My terminal looks scary. Let me clear it. So 7 digits are overflowing. 1, 2, 3, 4, 5, 6, 7. So we can fix it. We can fix it. Based on what we did earlier, we can suggest a fix. You know, long is going to hold a certain value. I think 9, I don't know the word, like having 18 zeros, 18 zeros, maybe pentillion or exillion. So it's going to hold like 18, like 9 exillion. But if you use unsigned long, it can hold twice as large, as we saw earlier when we're using unsigned int. So this is going to make it hold twice as large. So we recompile. Remember from the old compilation, we had 7 overflows. So did I do this? Oh, I think I didn't change the format specifier. I didn't change it because since I'm using unsigned long, we're not supposed to have negative again. So, but this format specifier for unsigned long should be UL. If it's not UL, please someone should confirm in the chat. Let me try UL because we have to run quickly. Oh, it's not UL. It wasn't even changing color. I was suspecting. Let me just Google it. Okay. Yeah, I think it's LU. I got close. I just, Okay, so it should be LU. Oh, thanks. I wasn't looking at the chart. Sorry. It should be LU. Because it was not changing color and I was, suspicious. So LU. Now the color makes sense. LU. So LU, and we are good. Okay, my screen is already clear. I compile, I run. So first of all, no more negatives. But these values look like they are all good. You just have to inspect very carefully. It still has overflows, So we've seen that this is an accurate output. So we're going to go back there. What's the next value? It overflows around 18 x billion. So the next value is this 12, wherever. I don't expect that to be able to print this 19 because its maximum capacity is 18 plus. So it's going to overflow here, but successfully it still prints this one. So, so that's it. It prints this one successfully. And this is the one that's supposed to be 19, but it's not printing it. So it had overflow on this 19. So that's not working. So then what do we do? You can sing shade the wine me. Or you can just, think. And if thinking doesn't work, which sometimes having gone this far, you'll be probably frustrated. You ask, you ask people, you ask your peers, they are as confused as you are. You then, ask the gurus. I was privileged, right, to ask our genius, and I got a hint that if you have a number like 1, 2, 3, 4, let's say we have 12,356, then I have a data type, right, that can only store 10,000 maximum. So how do I print 12,356? So what I got was I could actually use two variables to print it. So I could have A is equal to 12,356, right, over 100. Let's use 100 for instance. So in that case, what happens? Our A is going to hold the value 1 to 3, right, from normal maths. Those of us that didn't sleep in maths class, right? And then you have B. Let B now be 1, 2, 3. It's not going to be the same number, but it's not going to be division this time around. So if we have used division to get the first 3 digits, what are we going to use to get the last 2 digits? We're still using 100 as the factor. So it's going to be, let me look at the chart. Okay, nobody is saying anything in the chat. Well, somebody is supposed to say mode 100. So when you do B equal to mode 100, this is going to give 56. So then you now print, let me come here. Don't mind the order of these things. So you print A, comma B. You print A, comma B. So this is going to give so printing A is going to give us 1, 2, 3. And then printing B will now just add 5, 6. So you just make sure that in your printer, you don't put space, you don't put anything between your A and B. So your printer is going to be something like, if they are both int, something like percentage, where's that percentage? Percentage D, and then no space, nothing, percentage D, right? And then A, comma B. I remember to put the comma because that compiler was showing me, right? So this is how you're going to print it. And it's going to give 1, 2, 3, 5, 6. So this is a trick that we're going to use. Let me go over the algorithm again, or the algorithm. We want to print 12,356. and we're using a data type that cannot hold more than 10,000. So if you try to assign this to a variable, it's going to overflow. You're not going to be able to print it. So the trick is, instead of trying to assign it to one variable, assign it to two variables instead, such that your first variable is the number that you want to represent divided by 100. So in that case, it holds 1, 2, 3, which is way below 10,000, maximum, the ceiling. Then the second variable, you want it to be the last digit. So if you use division to get the first part, 1, 2, 3, don't use division again, right? You're going to use modulus this time around to get the last 2 digits. So you could also use 1,000. You could use 1,000. So in this case, this is also going to be 1,000. So if you use 1,000, this is going to be 12, and this is going to be 356. So either case, if you print A, you get 12. You join B to it, you get 356, and we are good. But we don't want to do it, for all of the numbers. We don't need to do it for all the numbers. We just have the output is correct up to this point. So we just have 1, 2, 3, 4, 5. We have the last 6 that are not correct, but we're not going to output the last 6. What you just get is that what you get. Let me try to show something quickly. Let me try to show something. What's this one showing? Cancel. So since we already got this, let me clear it. So assuming we have A is equal to 1, 2. Let me use 1,000. Let me use 1,200, and B is equal to 2,000. So our algorithm is saying that, I'm going back to the Fibonacci algorithm, the one we're using to get the current term. It's saying 10 will be equal to 3,200, right? 10 will be equal to 3,200. That's A plus B. Then what happens? A gets the value 2,000. Then B gets the value 3,200. And then when you recompute, you get, this should be 5,002. Then again, A gets 3,002. B gets 5,002. 10 is getting 8,004. Then what else? Okay, so now A is equal to 5,002. B is equal to 8,004. Now B will now be 3,004. So this is when there's an overflow. We are still dealing with a data structure that can only hold 10,000 as maximum. Oh, let me quickly plug my, I just completely forgot. Oh. Sorry guys, sorry about the interruption. I forgot about my, forgot to plug. Where is my? Okay, so we are dealing with this data structure that can hold 10,000 as maximum value. So this is supposed to evaluate to 13.6 normally, but since it can only hold 10,000, it will overflow and now hold 3.6. So what we notice now is that at the point where there's an overflow, our term, which has always been greater than B, it now at that point becomes less than B. Do you understand? So up until this point, term is always greater than B. But the moment there's an overflow, what you notice is that term becomes less than B. So we want to include that condition in our what's it called? In our for loop. So time is equal to A plus B. So I think we can put it right after we calculate time. Don't put it after you've assigned B to time. It's going to, it's not going to evaluate because time and B are now equal. Don't put it after line 17. At that point, B and time are equal. So just put it immediately after line 14. So if time is less than B, right? What we want to do is, let's break the loop for now. We want to break the loop. So now I want to run and compile. What I expect is, even though I put up to 98, it's not going to print this last 6. Anything above this 12, this one is not going to print it because we have told it to break. So let me recompile, clear my screen, and then execute. So it's stopping at this point when there's no overflow. So we're not going to use that algorithm to print the, to print the last 6. So after we've broken out of this loop, then we now want to have this Vim. So we now want to have our A, which is now so big. We want to divide it by 100 so that it becomes smaller. So this dividing A by 100, if A was our 12,356, right? It will now hold 123. So, but if I do this, I want to also do another variable. Let me call it D. D is equal to A mode 100. I want to do this also. So let me include 3 more variables that I'm going to use to print the second part of the big numbers. So let me include D, E, and F. So, but if I put line 23 before line 22, on line 22, the original value of A has been altered. So I won't be getting the actual last 2 digits. So let me just cut line 23. Let me put it before. So let me do it this way. So we have D is equal to A mode 100. So that holds the last 2 digits. Then I reduce B. And I've explained the purpose in case somebody does not understand. So this is like our A being 1256. And our B being 13458. Or let me just say they are still 9876. So they are close to becoming too big to fail, but they are going to fail, right? So I want to have a variable D that will hold 96. So it will hold 96 for me. So I would say D is equal to, what will I say? A mode 100. So that holds 96. And then what else? And then I will now say A is equal to, or divide equals 100. So that A is now equal to 88. So in that case, I can now keep working with A. It's no longer too big, to handle now. So, so this is what I'm going to do for it. So that's for A. Then for B, we're going to do the same thing, but this time around using the variable E. First of all, E is going to hold the last 2 digits. Then B is now going to be equal to this divided by 100. And this should be modulus. So I have new variables I can work with. Okay, so what else am I doing? Okay. So then I can repeat this loop. I can repeat this loop. Oh, this is this is now this command line is going to give me problem. 12 to 20 is 9 lines, right? So I can do 9 and do 9YY. And then, so I will reassign the values to smaller values so that I can work with them. And then I can paste. I can paste here. So a number of things will change in the second loop. First of all, K is not going to start from 3 again. K is going to continue from where it stopped. And to make a variable continue from where it stopped, you just put semicolon like this. So it probably stopped at 92, right? So it's going to continue from 92 and finish up the remaining part. So time is equal to A plus B. Now in this case, time is equal to A plus B is going to execute without overflow. Remember that we have reduced the size of A and we have reduced the size of B. So time is going to, and then I don't need this if condition again. You know, I don't need this if condition right here. I don't need this again. So, but also for the second time, I'm going to use the variable F. So if I'm using A and B to get the first part, then definitely D and E will be what gives the second part. So that will be D plus E, right? So this is what it is. So then I'm doing this movement. A is equal to B, B is equal to 10. I should also do the same thing for the second part. So what's the variable? So D now will be equal to E. If you follow the same, you know, our verbal reasoning from primary school, then E is equal to F. So you reassign like this. So now we want to, remember I said we want to print the 2 terms. So you want to print percentage U, and then I said no space, so percentage LU. So you want to print them first, followed by F. So this needs a fix. For the sake of time, I'm just going to explain the fix quickly and then apply it and then hope that there's no oversight error. So in this case, maybe I should use a smaller number. Okay, let me just use this. So this is 96, this is 88. So if you sum this, let me use 88, 8840, 8870. No, let me use 8040, 9070. So that I can calculate without calculator. So the normal sum here is supposed to be 17,110. It's supposed to be 17,110, right? So if you do the approach that we have been using, that you have C is equal to A plus B, where, you know, A is the first part, A is 80, B is 90. So that means C will be 170. And then you now do the second part, F. Oh, this is supposed to be 10. You now do the second part, F is equal to, what is F equal to? F is equal to 40 plus 70, which is equal to 110. So this is what you'll be getting as output. If you print 10 before F, you'll be getting 170, 110, which is not what you want. You want 17110, which is the actual value. But doing it that way will actually give you 170, 110. Do you understand? So the way to fix it is, you say that if F is bigger than 100, if F is bigger than 100, you want to do F mode equal to, if F is bigger than 100, you just want to use the 10 part. F is equal to 10. And then you want to carry 1. You want to carry the 1. So really we're pressed for time. So let me just put that condition here before we print. So after assigning F here, so we're going to have if F is greater than 100. So this should be true. We want to do two things. First, reduce it. F mode equals 100. F mode equals 100. Then what else? Then C will actually be, term will actually be A plus B plus 1. So because 1 will be carried over from the spillover, the fact that F exceeded 100. So this is what term should be. So if I assign, so then let me put this line 28 in an else. DD E else. So term should just be A plus B, except there's a carry from when F is bigger than 100. So this should fix it. So we assign A to B, B to term. And then one final fix. Sorry, it's just one more fix that we need to do to make it perfect. So we have said we want to get 17,110 and not 171. We don't want to get 170,110. So we have fixed it by saying that if this part is bigger than 100, just use the mode 100, right? Use the mode 100, which is going to be 10, and then carry 1 so that this one has 1 added to it. So that's the fix. But assuming this is something like 0.4 and or let me say, let's say this is 90, this is 90, and this is 24. Is this what I want? No, let's say this is 14. So if this is 19 and 14, then we'll be having 170 for the first part and 104 for the second part. So when you do F mode 100, you'll be getting, and then you add 1, you'll be getting 171, and then F will now have 4. F will have 4. So this is what the output will be in such a case. So to fix that, you can specify that, when F is 104 and you do mode 100 and it's giving 4, right? You can specify that printf should print it as 2 digits. It should print it as 04, so that it is the actual 04 that comes out, not just 4. So the way to code that is that you come here and say that the next one should be 2 digits long, like this. Then it doesn't know, printf doesn't know what it should put as the second digit in case there's no second digit, in case you have 4. Should it put 0 for it? Should it put, what should it put? It will put space by default. So to specify that you want 0 to be, the second digit, then you put 02 like this. So I think this should work. I hope there's no error because we're, really out of time. So if you do GCC and if you do a.out, okay, so as you can see, after the 1, 2, this 1 line that wasn't printing before is now printing. And I think all the values are good. Sorry for taking so much time, but I think this is it. Anybody has any question, you can please ask.
Whoa, Josh, no error at compilation. That's impressive.
So I'm going to stop sharing my screen. I can respond to the questions maybe with audio, right? So that my boss Dave can just wrap up. We're really sorry for taking your time, guys. You know, we're not like Julian, we're just learning. So we'll make it up next time. Sorry.
Oh, don't be sorry. Like the explanation was like right on point. You went like from like step by step, not rushing into, you know, the end of the like the last part of the explanation. So that was very good. So we saw, you know, the int, you know, what can be held into an int, and then like the unsigned int and the difference between the two. And you really explained that very well, I thought. And also like then you went too long and then unsigned long, and then like you showed everybody like, you know, there's still limitation. And we can actually use long, but then like we're still gonna have problems. And like, you know, you found this trick of like divided by 100 and you know, using the modulo, and then, you know, like creating your own addition with like the two parts of the numbers to actually solve the issue. So it was like I found it very, very clear, very, very smooth. So I don't know you guys what you think, but I think it was perfect. And I'm glad that, you know, we took a little bit more time than expected, because it was really well done. Like the three of you like did present very, very well. So I mean, congratulations. It's like it's very hard. It takes a lot of time to prep. Obviously, you did this very professionally. You know, like I was like witnessing you guys as you were, you know, getting better and better, and as you were like working on this. Like it's been like what 10 days, 2 weeks that you know we're working on this. So from like 2 weeks ago to here, like being able to like, you know, handle the pressure also of being live, and you know, like I'm seeing like more than 400 people like, you know, were watching today. So it's like it's I mean, congratulations, and I'm very proud of you. Like you all did like an amazing job. So like it's been like 2 hours and a half, so we're gonna have to stop here. Like we wanted to present Malloc, but probably we're gonna do this for another session, because like it's already very, very late. So I guess if nobody else has any question, let me just double check. No, everybody's saying like, well done, Josh, perfect, Josh. You know, we said the same to IB and to Alice. So yeah, congratulations. We'll do something, you know, another session. We'll plan it for whenever we can for the Malloc. This is also like a part that is like really, really cool. So I guess, you know, it's time to say goodbye. Thank you, everybody, and we'll see you very, very soon.